In this class we will see how to perform mechanical stress analysis on parts, using the SimulationXpress, which is a very important tool for engineering activities, because it allows to perform analysis of resistance of parts, according to the material and the applied efforts. With this analysis we can verify the tension that is acting and which regions are most critical, and if necessary make changes still in the design phase, eliminating subsequent rework and unnecessary costs. Let's go to class. Currently, the application of metal beams in the construction of buildings has been greatly expanded, and its use is already common in the construction of precast sheds and machine structures. In our case we will simulate what will happen with a beam of cross-section I, named so due to the geometric shape of its section, that is set on its two ends, when we apply the distributed load that will act on its entire upper face. The crimping is characterized by restriction to movement on both axes and also restriction on turning or momentum. In the Tools menu we click on SimulationXpress and note that the wizard is shown in the task pane. By clicking on Options, we can define the system of units, the location to save the results and whether we want to display the maximum and minimum values when plotting the charts. Clicking on Next, we proceed to the next stage, which is the definition of the fastenings of the part. We click on Add a fixture and select the faces of the two ends of the beam as shown, setting them to fixed. See that we can easily access the analysis and its settings on the left side of the screen. We click on Next and now we will apply the loading. See that we can apply force or pressure and in our case, we will apply force. We click Add a force, select the upper face of the beam, apply a force of 30,000 newtons and confirm. The next step is to set the beam material. See that we already have material applied to the piece, but if necessary, it can be changed easily by clicking on the option shown. We choose the IC 1045 and move forward. Using the standard SimulationXpress mesh, we perform the analysis. See that the progress box is shown. After the simulation is complete, the results are generated and the part is displayed animated. We click Yes, Continue, and now we can view the results by clicking on the respective options. See the deformation result and note that due to the crimping at both ends and the applied force, the beam tends to deflect. And the maximum value of this deflection occurs in the center of the beam. Therefore, when working with rafters, it is very important to perform deflection calculations due to the applied efforts and restrictions. Let's look at the voltage result, noting that unlike the maximum deflection, the maximum stresses occurred at the ends, where we have the fixation of the faces. Note that warm colors indicate the regions of greatest stresses. However, in this case, the voltages obtained are considerably lower than the flow voltage of the material, and the safety coefficient is very high. What is indicated now is to carry out the optimization study, but we will not show it in this course. After checking the results, clicking on Done Viewing Results, we can generate a report of the analysis by clicking on Generate Report. Note the generated report opened in Microsoft Word. We can also generate the eDrawings file of the simulation by clicking on Generate eDrawings File. By clicking on Next, SolidWorks asks us if we want to optimize the model. This subject will not be dealt with in this course, so we select No and click Next. See that the assistant informs us that the simulation is finished. If you want to redo it, just click Start Over. And so we finished this case study, where we trained the use of SimulationXpress. In case you need to design a beam, we suggest performing the effort calculations first, and then simulate and compare with SimulationXpress results.